Hello everyone, this is Dr. Lennon, and we are going to do a few examples with some triangles and rectangles today, just some basic geometry concepts involving Pythagorean Theorem, area and perimeter. So let's jump right in and look at this first example. So we have the measure of two angles of a triangle are 105 degrees and 31 degrees. Find the measure of the third angle. So remember the thing here is the sum of all three angles in a triangle is 180 degrees. So for this problem, we just add the two known angles and use a variable for the unknown angle and set that equal to 180. And now we just have a linear equation in one variable. So we can add together 105 and 31. So we get 136 plus x equals 180. And then we subtract 136 from both sides. So we get x is equal to, looks like 44 degrees. So that would be our answer here. Pretty straightforward application. And that's all. Okay, so the next example, so I didn't write any instructions here, but basically there's two parts, part A and part B, and what we want to do is find the missing side using the Pythagorean theorem. So remember, the Pythagorean theorem only applies to right triangles, meaning a triangle that has a 90-degree angle. So each of these are right triangles. So that is indicated by the little square shape in the corner of each of the two rectangles. That is the 90-degree angle. So the Pythagorean theorem says a squared plus b squared equals c squared, where c squared is the longest side, which is always going to be the one missing across from the 90-degree angle. So in this example, we have 9 squared plus 12 squared equals c squared. So we just kind of do the math. So 9 squared is 81, 12 squared is 144, and we have c squared still. So 81 plus 144 is going to be 225. So then we can figure out c by doing the square root of both sides. So c squared, take the square root. That's going to be the same as the square root of 225. So c is equal to 15. So that's the example for A. B, we have same sort of construction, 5 squared plus 7 squared equals c squared. So we have 25 plus 49 equals c squared. So this comes out to 74 is equal to c squared. So when you take the square root, this one doesn't come out quite as nicely as example A. So we don't. The real answer would be c is equal to the square root of 74, but that's not exactly an integer, but we can always get an approximation if we want by just using the calculator. And if we wanted to approximate to 2 decimal places, this would be about 8.60. So if I do a little squiggly equals, that means that's the approximate value of c. So if I said on a test or quiz or something like that, round to 2 decimal places, you could use 8.60 for this example. Let me actually include one more here, because we could have it where we're not solving for the hypotenuse, but one of the other sides. So let's say we had, a right triangle that looks like this. So maybe this is the right angle, and we know this is 25, and this one is 7. So if we're trying to find the missing side, let's call it y this time, then we would have 25 squared, so that's the hypotenuse. Sorry, let me erase that. So if we want to do a squared plus b squared equals c squared, then the shorter sides are the 7 squared and the y squared, and that will equal 25 squared. So now we have to solve for y squared, so this will be one additional step. We'll have to actually do a little subtraction as well. So we get 49 plus y squared is equal to 625. And then when we subtract 49, on both sides we get y squared is equal to 576. So when you take the square root, y will be the square root of 576. And that comes out nicely, actually. We end up with y squared is 24. So y is 24 for this problem. That would be our answer. So that's using the Pythagorean theorem. So you can either solve for the hypotenuse or solve for one of the legs, but you have to have a right triangle and you have to know 2 out of the 3 sides to be able to use that to get some new information. Okay, so the last few involve rectangles and perimeters and areas. So the perimeter formula, if you have a rectangle, and let's say the top and bottom. So rectangles mean you have a 4-sided figure where all of the angles are right angles. So you have 2 copies of the length and 2 copies of the width. So the perimeter here would just be twice the length plus twice the width. So that's the formula for the perimeter. So in this problem, they give you the width as 20 feet and the length as 35 feet. So we just want to find the perimeter. So the perimeter here is just 2 times 20 plus 2 times 35. So our perimeter is 40 plus 70. So here our perimeter is equal to 110. And both of those are given in feet, so we can include a unit in this problem. So our perimeter is 110 feet. And that's it for this example. Okay, so let's go ahead and look at this next one. So we have a rectangular poster. So we still know the perimeter for a rectangle, but this one actually involves the area as well. So if we have the length and the width, and this is a rectangle, the area is given by the length times the width. So this problem kind of has 2 parts. They give you the area and they give you the length, so they want you to find the width. So this problem actually only has 1 part, but potentially it could have 2 if they asked you what's the perimeter. So once you find the width, then you could also find the perimeter by applying the perimeter formula. But for this one, they just ask for the width. So we just fill in. So the area is 1316, and then the length is 28. So we get 28 times W. So if we divide both sides by 28, we have the width. So we end up with the width. And this problem is in inches. So remember that our unit should be inches here. So if you divide by 28, you get 47. So the width of this rectangle is 47 inches. And that is our answer for this example. Okay, so the last one, a little bit more interesting, a little algebra actually here. So again, the perimeter is 58 inches or meters. So let's write down our perimeter formula again. Perimeter is twice the length plus twice the width. And then they tell us the width is 5 meters less than the length. So the width is actually equal to the length minus 5. So the reason that's important is we can replace W by L minus 5, and that will give us a linear equation in one variable. So let's go ahead and replace P by 58. So we know that's equal to twice the length plus twice the width. And now we can replace W by L minus 5. And so when we do that, we want to make sure to include parentheses around it. Otherwise, the problem will come out wrong. So if you don't have parentheses, then you would not distribute and you would not get the correct answer. So the parentheses make us distribute that too. So this is going to be 2L minus 2 times 5, which is 10. So we can add 2L and 2L, so we get 4L minus 10. So to solve, we'll add 10 to both sides. So we have 68 is equal to 4L. And then we want to divide by 4. So when we divide by 4, what do we get? Well, we get L is equal to, I believe, 17. So we're not quite done yet because they also want us to find the width. So we need to plug the 17 back up into W equals L minus 5. So W will be equal to 17 minus 5. So our width is 12. And they tell us this is in meters. So the width is 12 meters and the length is 17 meters. The problem asks you to find the dimensions of each. So 17 meters by 12 meters is the dimension of your rectangle. So again, this isn't meant to be too difficult, but we just have a little algebra, and mostly these things resolve into linear equations. So the pertinent formulas for the triangle, we have a squared plus b squared equals c squared, the Pythagorean theorem. And for the rectangles, we have the area is length times width, and the perimeter is twice the length plus twice the width. So let me know if you have any questions about the homework. Otherwise, this is Dr. Lennon signing off.